In this try it exercise, we are given sets of ordered pairs, and we are asked to determine if each set represents a function, and if it does represent a function, if the function is one-to-one. So essentially what we're looking for, if we're just strictly going by the actual values that we're given, to determine if it's a function, for each input, there will only be one output. So if we look at part A, if we look at the set that we're given 3, -6, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4, and 3, 6. So what we want to know is it a function? So is it a function? We'll look at the individual inputs. Are any of the inputs repeated? We go -3, -2, -1, 0, 1, 2, and 3. So therefore, there aren't any extra inputs. There's no repeated input. So since there's no repeated input, we know that yes, it is a function. And the reason we know that it is a function is because there's only one output for each input. There's only one y value. One y value for each x value. Now we're also asked, is it one-to-one? So how do we know if it's one-to-one? We go the opposite direction. For every output, there should be only one input. So are there any repeated outputs? We have 6, 4, 2, 0, -2, -4, -6. So there are no repeated outputs. So yes, it is one-to-one because there's only one x value for each y value. Now, if we want to see this visually, let's just plot these points real quick. Just a rough sketch. So -3, -6, -2, -4, -1, -2, 0, 0, 1, 2. And I would suggest using graph paper, but we're just doing a rough sketch here to verify that for each input, there's only one output, and for each output, there's only one input. And how we could look at this, as far as a function is concerned, we know it's the vertical line test, and it passes the vertical line test. For a one-to-one function, it would also pass the horizontal line test. And in this case, it does pass the horizontal line test. All right, so again, let's look at part B. We have -4, -8, -2, -4, -1, 2, 0, 0, 1, 2, 2, 4, and 4, 8. So is there only one y value for each x value? Is there only one output for each input? So are any inputs repeated? We have -4, -2, -1, 0, 1, 2, 4. So no inputs are repeated, and therefore, yes, it's a function because there's only one y value for each x value. Now, what about the other way around? Is it one-to-one? Is there only one x value for each y value. So do we have any y values repeated? We have 8, 4, 2, 0, 2. Uh-oh, there's one repeated. There's one repeated at 4, and there's one repeated at 8. So basically, the y value is repeated for every one of these points except 0, 0, the origin. So that means no, it's not 1-to-1 because there's not only one x value for each y value. Or you could say there are multiple points with the same y value but different x values. And if we graphed this, we would see this is essentially a parabola, or at least the dots are points on a parabola. We have 0, 0, negative 1, 2, 1, 2, negative 2, 4, 2, 4, negative 4, 8, and 4, 8. So as you can see, it passes the vertical line test, but it would not pass the horizontal line test because the horizontal lines pass through these points of symmetry of the parabola. So again, vertical line test to see if it's a function, horizontal line test to see if it's 1-to-1, if it is a function. In this case, with our first set of points, we can see it basically forms a line. The sketch is a little off because I didn't use graph paper, but we can see that it passes the vertical line test for each y value. There's only one x value. And it is 1-to-1 as well because it passes the horizontal line test for each x value, or there's only one x value for each y value. With our second set of points, it passed the function test, the vertical line test, because for each x value, there's only one y value. But it's not 1-to-1 because there are multiple y values with different x values. And again, that means it doesn't pass the horizontal line test as well, meaning that it's not a 1-to-1 function.